There, folks. I hope everybody's doing well these days. So today I'm going to do a brief explanation for the start of workbook section 4.3. We're just going to go over questions. We'll do the little introduction and we'll go through questions 1 through 9 today. And then we'll pick up tomorrow and do a bunch of the other ones. So today basically going to be third hand rule, which involves charged particles moving into magnetic fields. So 4.3 is titled Moving Charges in Magnetic Fields. So we'll treat with wires, conductors in magnetic fields separately later. So if we take a look at what they're offering us here for information, the direction, finding the direction of the force, the magnetic force acting on charged particles, we use the third left-hand rule, but only for negative particles. We're going to use our right hand. You're going to see several types for positive particles. So the left thumb, the thumb is going to be the direction of the electron flow, or in the case of a positively charged particle, in the direction of the charge that we'll be talking about, the alpha, or we'll talk about some lithium ions in there as well. The fingers indicate the direction of the magnetic field, and then the palm is the direction of the magnetic force. So when I used to explain this to class in person, I would say, okay, just like the first hand rule, your thumb is the direction of the charge. If all the lights were out and you had to just use your hands to feel around the room to find out where you're going or find where your flashlight was, you field with your fingers. So your fingers are in the direction of the field. And the magnetic force, I used to say, well, when you're hitting a student, never close a fist because it will break your knuckles. So you should always hit them with your palm. So your palm is the direction of the force. Don't really endorse hitting students. It's just a joke. Relax there, Uncle Drager. So the thumb is the direction of the charge. Left hand for electron flow. Right hand for positive particles. Fingers in the direction of the magnetic field. And then your palm points in the direction of the magnetic force. Notice that all three of these are perpendicular to the other two. Each one of these is perpendicular. So the electron flow is perpendicular to magnetic field and force. The field is perpendicular to the charged particle flow and the force. And the force is perpendicular to the field. So they all three have to be one in the x, one in the y, one in the z. That'd be your x, that'd be your y, that'd be your z planes. Now there is another method which is really common out there. So if you have a friend or an uncle or parent who's a power engineer, they may use a slightly different system. So instead what they do is they point their pointer finger in the direction of the magnetic field. The middle finger is perpendicular to that, and that'd be the electron or the force. And then your thumb would be perpendicular to both of those. So it's kind of a pointer with a side finger coming out as well. It's also a very common method that's used in a lot of places for different people. If you do look up some videos on this, be very, very careful because they are using right-hand rules an awful lot. And there is some misconception of the British and American videos might be just a little bit off in terms of your hand rules. They'll be fine for third hand rule, but for first and second, you'll find some error. So in terms of the formula, and we went over this a little earlier, we've done some bell work on this right already, that the magnetic force is equal to QVB. Now they put the perpendicular symbol beside the V. We used to put it beside the B. It doesn't have to be perpendicular. It just can't be parallel. For the maximum force, the charges have to be perpendicular to the field. That's all we deal with in Physics 30. Some university courses, some of the videos you're going to find, they'll have them at other angles as well. Then it's just a little bit of trick work to figure out. It's not that difficult, but the decision was, let's just keep it at perpendicular. So all of our questions in Physics 30 will be perpendicular. So the charge is traveling perpendicular to the field. So the magnitude of the magnetic force, where Fm is the magnetic force working on the particle. They made a little typo there, and they put wire. That, of course, would be for next section, 4.4. B, you could have the absolute value signs and the vector arrow, is the perpendicular magnetic force to the direction of the charge velocity. Q is the charge, again in coulombs. And V is going to be the speed of the particle perpendicular to the field in meters per second. So let's start to solve some of these problems. So question number 1, electrons travel through a uniform field represented by the x. So again, you remember through our conventions for that. X means that it's going away from you. So in this case, we're going to call that into the page, or they're calling it directed into the ground. They show that north is up here. So I find it really helpful to actually put in north, south, east, and west, right around the area that you're dealing with in that case. So we're going to start with P in question A. So in terms of P, we see that the particle is moving in that direction. What kind of particle is it? It's an electron. So let's use our left hand. So now what you want to do is you want to point your thumb in the direction of that. So that's going towards the top of the page, which is north. So particle P, use the left hand for electrons. Your thumb, direction of the particle, so the thumb is always the direction of the particle, points to the top of the page, which is north. Now this magnetic field, which is here, again, because it's an X, it's like an arrow going away from you. So all you see is the feathers making the X. That means into the page. So your fingers have to point into the page, your left hand, with your thumb pointing towards the top of the page. That leaves your palm going towards the right-hand side of the page, which is east. So I've written that out for you here. Just going to move this out of the way. So particle P, left hand for electrons. Your thumb the direction of the particle points to the top of the page, which is north, and your fingers, direction of B, magnetic field, point into the page. So when you hold your hand looking at that, this leaves your palm pointing towards the east side of the page. So take a few minutes, hit pause, and copy that down. So we get to B, make that blue. We've got particle Q. So again, it's an electron. It's traveling in this direction. So using your left hand, because it's an electron, point your thumb towards the left-hand side of the page, which is the direction of the charge. Your fingers point into the page again. So with your thumb pointing towards the left-hand side of the page, towards the west, your fingers going into the page, that leaves your palm going upwards towards the north. Just take a couple of seconds, hit pause, view that. And then you can hit pause again and copy this out for particle Q. Again, use the left-hand rule for electrons. Your thumb, direction of the particle, points to the left side of the page, which is, again, west. Your fingers, the direction of the magnetic field, are pointing into the page. Leaves your palm pointing towards the top of the page, which we've identified as north. So take a few seconds to copy that down, hit pause. So question number 2. Again, we've got a P and a Q taking place, so A is for P. Again, identifies as electrons. You can use your left hand. Your thumb points in the direction. So this is your thumb pointing up towards the top of the page, which we've identified again as a north, a south, an east, and a west. Now your fingers of your left hand with your thumb pointing upwards are going to point towards the west, towards the left side of the page. The only way to accomplish that has your palm pointing into the page. So it'll be into the page, which they want to call down. So take a second, try and manipulate your hands to do that. So I wrote that out for you. Particle P, left hand rule for electrons. Your thumb, the direction of the particle flow, points to the left side to the top of the page, which is north. And your fingers, the direction of the magnetic field, point to the left side of the page, west. Leaves your palm pointing into the page, which is how I would like you more likely to call it, but sometimes the workbook is going to call that down. So hit pause, copy that down, please. So question B deals with particle Q in this case. So Q in this case is moving from the west, going towards the east, and the magnetic field is parallel to it. Here's the thing, folks. In order for the to be a magnetic force, there has to be some directional difference from the parallel. As long as it's parallel, there's no force. Now again, I said earlier, in terms of physics 30, they'll always be perpendicular. However, other courses, further courses, will actually go at some angles. So you could have an electron going at an angle like this. It wouldn't be the maximum force. The maximum force is going to be perpendicular, either coming from the bottom or coming from the top, coming from the south or north in this case. We could figure that out. It just takes a little bit of trig. We don't bother. So if you'd like to copy that out, for B, particle Q, this particle is moving parallel to the field and will not experience any force. So take a minute, hit pause, and copy that down. Question 3 just wants to compare what happens with a charge entering an electric field versus a charge entering a magnetic field. So remember that in terms of electric fields, they go from positive to negative. So this charge is going to go into a parabolic curve towards the positive plate. It would be caused by charged plates, negative plate down here, positive plate up here. But a magnetic field will always go in a circular. So that's an important curricular item. Charges in electric fields enter a parabolic curve. And those charges going into a magnetic field enter a circular curve. So write that down and remember that, please. Electric fields, charges go into parabolic. Magnetic fields, they go into a circular curve. So you can now use your circular motion formulas for a magnetic field. You cannot use in an electric field. You have to use your two-dimensional kinematics to solve some of the more difficult questions. Sorry, folks. So the first thing I want you to do when you're answering these questions, go ahead and write your north, south, east, west so we have some kind of frame of reference to work with. We know that we have electrons, so we're going to use our left hand. Electrons are traveling east. Traveling east. When they come into contact with a magnetic field which is going north. So that's our magnetic field. I'll hit pause, give you a second, copy that down. Once you copy that down, try and use your left-hand rule to figure that out. Remember, your thumb goes in the direction of the charge. Your fingers go in the direction of the field. What direction is your palm? Hit pause for a couple of seconds and make a guess. Okay, so hopefully you did that. Again, thumb going towards the east, towards the right-hand side of the page, your fingers going up. That leaves your palm flat against the paper. So what I like to call that is into the page. However, your workbook likes to call that down. Take a minute, copy that. So we start off, we read that it's a beam of alpha particles. And the first thing you have to realize is because it's alpha particles, you now have to use your right hand rule. Anytime it's positive, we're using the right hand. So the question tells us those alpha particles are moving south. So I've drawn that in place here, alpha particle going south. That's going to be the direction of our right thumb. The magnetic field, it says, is directed from the ground, which means coming out of the page. When it's coming at you, all you see the arrow is just the point. So we draw that in as a magnetic field coming out. We're going to put a little B over here to say that thing in green there is the magnetic field. So now look at it. Your thumb is, your right hand is going down, and your fingers are pointed out at your face. Take a second and make a prediction. Hit pause. So when you're doing that, now you've got your thumb pointing towards bottom of the south, bottom of the page. Your fingers are coming out of the page. That's going to leave your palm going towards the west or towards the left side of the page. Okay, copy that down. Question number 6 has some chloride ions. Chloride ions are negative, therefore you're going to use your left hand. I drew my north, south, east, west frame of reference on there, the chloride ions. So I'm going to stick my left thumb. It's pointing towards the east, towards the right-hand side of the page. They encounter a magnetic field that are going towards the south, towards the bottom of the page. So now stick your thumb towards the east, your fingers towards the south. That leaves the palm coming straight out towards your face, so that's out of the page. Again, the textbook likes to call that upwards. Copy that down. So question number 7, lithium ions. So now we have to use, remember, positive. You have to use your right hand. So I drew my north, south, east, and west. The lithium ions here, it says, are moving into the page. So we like to symbolize that with an X. Going in, it's just the arrow that's going away from you. If there was an arrow shot away from you, the arrow coming towards you would be a point, so it's going into the field. So now you're going to take your right thumb and put it towards the page. Magnetic field said was directed towards the east, so I've drawn that in green. So now I've got my thumb going in to the page, my fingers pointing towards the east, to the right-hand side of the page. That leaves my palm, which is facing towards the bottom of the page. The bottom of the page is south, so it's going to be towards the south. So again, thumb was going into the page. Fingers were going towards the right-hand side of the page. That leaves my palm going towards the south. That means that's the magnetic force is down. Remember, these three have to be perpendicular. So this is going down on the Y plane. These are in the X plane. That's going into the page on the Z plane. The only two possible answers it could be would be the bottom of the page or the top of the page, and still all three would be perpendicular. Question number 8. We've got a beam of alpha particles, so we have to use the right-hand rule. They're going towards the north. In this case, we're going to try and find the direction of the magnetic field. So it tells us the force is deflected into the ground. So the force, the magnetic force in this case, I'm going to symbolize here with my X, that's my magnetic force, is into the ground. So take your thumb, point it towards the north. Your palm has to go into the page. So put your palm against the page. That leaves your fingers pointed towards the east. If your fingers are going this way, that's your fingers. That's going to be the magnetic field. So the magnetic field is going towards the right-hand side of the page, which is east. Play with that a little bit to make sure that you got that one. Just a reminder that your fingers then are the direction of the velocity of the particle. Your palm is the magnetic force, and your fingers are the field. So again, always go back to that as your reference, your frame of reference. So question 9 is a little bit different. It's going to give us the following reference. So I'll put my frame of reference on there again. I've got west, north, east, and south. I've got my magnetic field coming out of the page, as they say, directed upwards. And it says that the magnetic force is going to be towards the east. So if the magnetic force, Fm, is towards the east, they want you to say, you're going to use your right hand, you're going to use your left hand. Are they positive or negative? So take your thumb, both hands, point them upwards. You're going to have to direct that field, fingers back towards you. When you do that, you'll find that your left-hand palm for right particles is going towards the west. Your left-hand palm, which would be negative particles, towards the west. Your right-hand palm would be towards the east, which is what we want. So therefore, it has to be positive. you have to use your right hand to make that work. So think about that a little bit, copy it down. That's all we're doing today, folks. I'll give you a couple of quick questions on bell work on that to follow up on it today. And then tomorrow we're going to skip a couple of questions and then we're going to move on and do a bigger chunk of this 4-3. So have a good one. Stay safe.